Hello teacher, hello students. This is a mathematics tutorial series which is organized by Oromia Education Bureau. I'm Dr. Garuma Abdisa from Matu University, and our topic in this tutorial is about rotations. That is one of the topics under transformation of the plane. A rotation is defined by its center, because when you want to rotate something, it must have some center, which we call it O. The single invariant point means a point which will not take part in the rotation process, and an angle of rotation. We note that there are clockwise and anti-clockwise rotations, and we usually take the anti-clockwise rotation as positive and the clockwise rotation as negative. And here is the simulation of how clockwise and anti-clockwise rotations happen. Clockwise rotation is in the sense of the way this kind of wristwatches rotate, and an anti-clockwise rotation is in the opposite direction of the way clocks rotate. The major concern of transformation of the plane as we talk about rotation is that, for example, if you are given a certain point A of x comma y, and then if you rotate that point and bring it up into here about the origin O, then finally what will happen to the mirror image of that point as we rotate it? That is, finally we will get a new point, a new coordinate system, that is A prime of x prime comma y prime, and this is the image which is obtained upon rotating the point A, which has a radius r, and here is at an angle alpha, and this one has an angle theta, and altogether we are at an angle of theta plus alpha. So in this case, the coordinates of A, because if I bring it this way, and that will form 90 degrees, and the cosine of alpha is adjacent, that is x divided by hypotenuse, x divided by r, so x is r times cosine of alpha. That is the way we write it here. And similarly for y, sine of alpha is equal to the opposite, that is y divided by hypotenuse, y over r, so y is r times sine of alpha. That is the way we decompose the original coordinate of A into its components x and y. In a similar way, if I wanted to decompose this point by making 90 degrees at there, because now everything that is from here to there are at an angle of theta plus alpha. So altogether, if I want to find in a similar way as I've showed you for this one, because now the whole angle will be at theta plus alpha, so the x prime, that is for this point, this point is x prime, will be r into cosine of alpha plus theta, and y prime, that is this all length, will be equal to r into sine of alpha plus theta. So I can write this x prime, which is r cosine of alpha plus theta, as we are able to decompose cosine functions into cosine of this sum of angles. Cosine of alpha plus theta is always equal to cosine alpha cosine theta minus sine alpha and sine theta. Cosine of alpha plus theta is cos alpha cos theta minus sine alpha sine theta. So by using that kind of trigonometric identity, we can write as this one as cos alpha cos theta. This is a plus, now I will make it a minus, then sine alpha sine theta. And then by bringing these two terms together here, but that was already r cosine alpha, which is something we already got, I wrote it in blue color, and the blue color refers to x, and that is afterwards be equal to x, this x, which is also written in blue, minus r multiplied into this one, r sine of alpha, and that r sine of alpha, which is written in magenta color, will be equal to the y, which is this one. So we can directly write y prime, which is r sine of alpha plus theta, as these two, and then r sine of alpha will be y. So finally y prime is y into cosine of theta plus x sine of theta, and x prime is x cosine of theta minus y sine of theta. That is a very simple and straightforward substitution of, we first expand these two, and then we will substitute a part of them by this one and this one. That is simply the way these problems are solved. And then what happens is, finally, we can rewrite our expression as x, which is x cosine theta minus y sine theta. Y prime is equal to x sine theta plus y cosine theta. Or in matrix form, we can represent it as, in column matrix, x prime and y prime is equal to cos theta minus sine theta and cos theta, and x, y here. You multiply this one by that, this by that, and then you will get x cosine theta. You multiply this one by this, and this one by that. That is minus y sine theta. Again, you multiply this one by this, then you get x sine theta, and the second term by this one, which is y cosine theta. So whichever is convenient for you, either in that form or in this form, they are equivalent. What they tell us is, we originally have a problem that, for example, at this point we have a of x comma y, and then I will rotate it somewhere, and finally I have a final point of a prime, which is x prime comma y prime. And then after rotation through an angle which is, this case is alpha, in between here is theta, and altogether they are alpha plus theta. And then x and y are given to me, r is given, alpha and theta are given, and then I want to determine what will be the values of x prime and y prime. That is originally the essence of this problem. And it turns out that the x prime term will be equal to x, which is already the known quantity, times cosine of theta, something given, minus y, that is this part, which is already known, times sine of the angle, which is given to us, will give me something that I do not know, which is this point. And y prime is equal to x, which is the known part, times sine of the angle, which is known, plus y, taken from the known part, times cosine of the angle. So I will be able to know this new coordinate in terms of what is already there after rotation, and that is the essence of how rotation works. Let us apply this into different cases. The first case being whenever the angle of rotation is theta equal to pi over 2, and that is about 90 degrees, and x prime is equal to x cos theta minus y sine theta. You directly substitute pi over 2 into the values for cosine and sine, and it turns out that because cosine of 90 degrees is 0 and the sine of 90 degrees is 1, x prime will be equal to simply minus y, because the sine of pi over 2 is 1 and the cosine of pi over 2 is 0. This term will be 0. This is y times 1, which is minus y. The same is true for y prime. You directly substitute 90 degrees, that is pi over 2, for sine and the cosine. And sine of 90 degrees is 1. Cosine of 90 degrees is 0. X times 1 is x. Y times 0 is 0. So I'm left with only x. So it means that if you rotate something 90 degrees, that is pi over 2, a point which is x comma y will be mapped to a new point which is minus y comma x. That is, for example, if I have a point x comma y here, and then if I rotate it through 90 degrees, finally what I get is minus y comma x. The x coordinate will be minus y, and the y component will be x. It will be mapped to minus y comma x after I rotate it for about 90 degrees. And the second case is when theta is equal to pi, that is 180 degrees. In a similar way, now you substitute for cosine, that is pi, and for sine again pi, and the cosine of pi is minus 1. and the sine of pi is now 0, and I'm left with minus x. The same is true for y prime. When I directly substitute for y prime, you directly substitute pi here and a pi there. X times sine of 180 degrees plus y times cosine of 180 degrees. You get these two expressions. And then x sine pi is 0, cosine pi is minus 1, so I'm left with minus y. And it turns out that a point x comma y after rotation about 180 degrees will be changed into minus x comma minus y. That is, for example, if you have one point x comma y here, after rotation through 180 degree means you rotate through over here, and then you will get minus x comma minus y. That is rotation about 180 degree will be quite opposite of across the line joining the 2 pointers. That will be in the other side, so it will be x minus x and the minus y. It will be in this quadrant, for example. The third case is whenever theta is 3 pi over 2. As usual, you directly substitute for theta 3 pi over 2 and for theta again 3 pi over 2. And because cosine of 3 pi over 2 is 0 and the sine of 3 pi over 2 is minus 1, you are left with minus y times minus 1, which is y. And similarly for y prime, you will get that to be minus x. And x comma y is now mapped to y comma minus x. If you start with a coordinate point x comma y, it will be mapped to a new coordinate after rotation through theta is equal to 3 pi by 2. It will be y comma minus x. When theta is 2n pi, whenever n is an integer, that is an integral multiple of 360 degrees, x prime is equal to x cosine theta minus y sine theta. You directly substitute 2n pi, which is an integral multiple of 360 degrees, 2 pi. And after reducing this, you will get this to be x, and y prime is equal to y, because sine of 360 degrees is 0 and the cosine of 360 degrees is simply 1. By substituting those values, you will get x comma y to be the same, because it means that, for example, if you have 1 point x comma y over here, after rotation over 360 degrees will be back to the same point. So the same point, x comma y, x comma y. This is a formula for rotation about a point AB. Previously, we have been talking about whenever rotation happens about the origin, that is about a point 0, 0, that is the origin itself. But now, what if the rotation is rather than being about the origin, it becomes about any other point? For example, if this is the xy plane, my rotation must not necessarily be about this origin, but what about if it were just rotating this point, x comma y? What about if it is rotating about this point, which is called a comma b? It's rotating about this point rather than about the origin, not necessarily always about the origin. There must be a way that we can make our rotation point, the center of our rotation, to be any other point. So when that happens, we can rewrite our expression in this way, and I will tell you how this is derived. For our expression, whenever the rotation is about the origin, we had x prime is equal to x cos theta minus y sine theta, and y prime is equal to x sine theta minus y cosine theta. But now we add, for the x terms, we subtract minus a terms wherever there are x's, and wherever there are y's, we subtract b terms. And I will tell you a few minutes later why this has to be true. In general, the formal way for making an anti-clockwise rotation about the origin is that there are no a's here, because x prime minus 0, simply x prime, here minus 0, simply x. But whenever our rotation is about a comma b, our formula will be this one. This is rotation about any other point A comma B. Actually, this works if our rotation is about the origin or about any other point. This is a general formula. This is general formula. So in this general formula, we can have x prime minus a is equal to x minus a into cos theta minus y minus b sin theta. Y prime minus b is x minus a into sin theta plus y minus b into cosine theta. If the rotation is about the origin, make the a's and the b's to be 0. If otherwise a and b are a new coordinate system as the center of our rotation, just keep them, and that is the general formula. And the way this formula is derived is, first of all, we have to translate the given origin back to the given coordinate system a comma b back to the origin, and then we rotate it, and then we translate and back it into its original place. So remember this TRT. First translate, then rotate it, and then translate it back to the original position, and then you will get this answer very easily. So translate the center a comma b to the origin by a translation vector minus a comma minus b, so that any point a comma x is translated to the point x minus a and y minus b. Secondly, rotate the new translation point in step 1 about, that is this point, the origin through the angle theta, and translate the result obtained back to its original position by a vector t of a comma b. And then these are the two formula in comparison. If you are making a rotation about the origin, you will take this formula, that is about the origin. This is about the origin. And this formula is about any other point. Of course, this one is for now about the point rotation of this point x minus a, y minus b, about the origin again, about the origin, because I'm using the second step. And then thirdly, I have to translate back into this original place. That is, I will add the a term and the b term here. And then after subtracting a from this side and the b from that side, I will get this formula for any rotation about any point a comma b. What happens is x prime minus a is equal to x minus a into cos theta minus y minus b into sin theta, and y prime minus b is equal to x minus a into sin theta plus y minus b into cos theta. This one applies both for any other point a comma b and also for the origin, because the origin is simply to mean whenever a becomes 0 and b is also 0. So this is the general formula, I can say. So let us apply. For example, find the image of the point 3, 4 whenever it is rotated through theta is equal to pi about 6, 5. And the point A, which is x, y, is now this 3, 4, where my x is 3 and my y is 4, of course, from this one. And the point of rotation is now a, b is 6, 5. The problem is I wanted to rotate the point 3, 4 about the point 6, 5. So by directly substituting into our formula, x prime minus a is equal to x minus a into cos theta minus y minus b into sin theta. X prime minus my a is 6, x minus a, 3 minus 6, because my x is 3 minus 6, times cosine of theta. My theta is pi, because it says that theta is about pi. And then after directly substituting everything you have, you will get x prime to be equal to 9. Similarly, for y prime, directly by substituting the results, you will get y prime is equal to 6. It means that if we make a rotation of the point 3, 4 about this 6,5, we will get a new point which is 9,6. We will get 9,6. This is another example, determines the image of the line. Previously we have been rotating a point about another point. Now I wanted to show you what will happen to the image of the line y is equal to 3x plus 1 after rotation through theta is equal to pi over 2 about the point 2, 2. This 2, 2 is nothing but it is this is a comma b, where my a is 2 and my b is also 2. And in order to find the solution to this problem, I will pick up two random pointers from my given line, that is y is equal to 3x plus 1. If I choose x to be 0, 0 times 3 is 0, plus 1 will be 1. Then one of my pointers of choice is b1, b1 of 0, 1. If I choose x to be 1, it will be 3 times 1. 3 plus 1 will be 4. That is my second point. And as I told you, my a comma b is 2, 2, where a is 2 and b is 2. I will directly substitute that into my formula. With direct substitution of numbers, I will get x prime to be equal to minus 3. I mean x prime is to be equal to 3. Similarly, for y prime minus b is equal to x minus a into sine theta plus y minus b into cosine of theta. With direct substitutions, you will get y prime to be equal to 0. These are simply direct substitutions. So it turns out that after making this rotation of this point 0, 1 about the given center of coordinates, that is 2, 2 in this case, then I will get a new point that is 3, 0, which is this one. Because we chose 2 pointers from the line, for one of them we already got 0, 1 after rotation becomes 3, 0. Now I am left with this point, that is 1, 4. I am going to make a rotation of it again. So for b2 of 1, 4, x minus a, which is x minus a into cos theta minus y minus b into sine theta, with direct substitution again, I will get x prime which is equal to 0. And y prime minus b is this one. With direct substitution again, I will get y prime to be equal to 1. So my point b2 prime, which is 0, 1 is 1, 4. That is the image of 1, 4. I picked up this point which is 1, 4 after rotation. I found out that its image will be equal to b2 of 0, 1. So next, in order to find equation of a line for the new 2 pointers, that is for b2 prime and for b1 prime, I will use the slope of 2 given pointers, 2-point form of slope equation, y2 prime minus y prime over x2 prime minus x1 prime. That is 1 minus 0 divided by 0 minus 3, and then I will get the slope to be equal to minus 1/3. So y minus 1 is equal to minus 1/3 of x minus 0. That is equation of the line, and then the new line will be equal to minus 1/3 into x plus 1. The other problem is find the image of the circle. This is equation of a circle, x plus 4 the whole squared plus y minus 6 the whole squared is equal to 9 whenever it is rotated through theta is equal to pi about minus 7, minus 3. And the center of this circle is minus 4 and positive 6. Always whenever equation of a circle is given in this form, x is equal to, for example, minus 4 and y is equal to 6 will be the center. This is the center of the circle, and the rotation, our rotation point will be about a comma b will be about minus 7, minus 3, and directly substituting into x prime minus a into, which is x minus a into cosine theta and y minus b into sine theta, we will get x prime is equal to minus 10, and y prime will be similarly equal to minus 12. That is simply a direct substitution into our formula, and thus the point negative 10 minus 12, that is this one and this one, that are the images of the center of our circle. The circle is there, and then we rotated it, then it will be mapped to a new center, and the equation of the new circle will be then, because the new center is this one, x plus 10 the whole squared plus y minus of this one, y plus 12 the whole squared. But as you see, the radius will be equal. The radius of the circle before rotation and after rotation will be equal, because rotation is a kind of transformation of the plane that preserves distance. Another example is, which is the image of the circle with equation x plus 2 the whole squared plus y minus 2 the whole squared is equal to 1 whenever it is rotated through theta is equal to pi over 6 about the origin now. So a comma b will be simply equal to 0, 0, and these are multiple choices. So you can take some time to solve this problem, and you will choose if the answer is A, B, C, or D. You will circle it by yourself, and then I will show you the answer after some time. Okay, let us see the solution of this problem. Center of the circle is minus 2, 2, and our rotation is about the origin, that is about 0, 0. So directly by substituting the values into the formulas that we have, because cosine of pi over 6 is root 3 over 2, and sine of pi over 6 is a half, and then we will directly substitute that into this formula, and this formula is a general formula. We will use it for everything, because if it is about the origin, the a and the b will be 0. So in this case, my a and the b will be 0. And when I directly substitute everything I have, then I will get x prime to be equal to minus of root 3 minus 1. Similarly, solving for y prime by directly substituting into my formula, I will get y prime is equal to root 3 minus 1. These are direct substitutions. You simply make cosine of pi over 6 replaced by root 3 over 2, sine of pi over 6 by a half. A and the b's are simply zeros, and the centers are minus 2 and the positive 2. These are simply direct substitutions of the numerical values. So finally, I will get y prime to be equal to root 3 minus 1. So center of the image is minus root 3 minus 1 and root 3 minus 1. So the image of the circle will be this one, and therefore the answer has to be C. The other problem is when rotated through an angle theta anticlockwise about the point 2, 3, the image of the point 1, 2 is 2, 3 minus root 2. Find the angle theta. That is the problem. Now the angle is required. So the solution is we directly substitute x to be 1 and y is equal to 2, and a is 2 and b is 3 because of this. This is a and this is b. These are the formulas that we already have, and we already have everything to plug in except the angles. Now x prime and y prime, a and b, everything is known except the angles, and then by directly substituting, what we will get is cosine of theta plus sine theta plus 2 is equal to 2, and the y prime is equal to minus sine theta minus cosine theta plus 3 is equal to 3 minus root 2. So by eliminating these similar terms, I'm left with minus cosine theta plus sine theta plus 2 is 2, and minus sine theta minus cosine theta plus 3 is equal to 3 minus root 2. By reducing this expression, I will finally get minus cosine theta plus sine theta is 0, and sine theta plus cosine theta is equal to root 2. Since sine theta is equal to cos theta and their sum is equal to root 2, I can, for example, subtract one from the other, so that sine theta will be equal to cosine theta, and then this will be equal to root 2 over 2. And then theta is simply pi over 4. That is what is requested, and it is very easy to verify that theta is equal to pi over 2, because if theta is root 2 over 2, theta is simply the cosine inverse of root 2 over 2, which is pi over 4 or 45 degrees. This brings us to the end of this lesson. Thank you very much, and keep doing other similar exercises by yourself.